But today we're here to talk about advances, changes, improvements, if you will, in the commercial roofing market. By title, it's a little bit of a sinister title, isn't it? It's not a cover-up. It's a little of a spy novel. Well, it's not really a cover-up, but what it is saying is that the roofing systems that we've known over the years, through the decades, and quite frankly now, asphaltic roofs have about a 100-year history or more to them. Those are rapidly being transformed and transplanted by other newer technologies. And we're going to look at those and advance those today. We're also going to look at the fact that it's no longer just a matter of putting a roof on the building. It's no longer just a matter of putting a blanket on the bed, if you will. It's not a cover-up. It's part of a whole system, a unitized system. And it starts at the deck and it works its way up. And by the time that we finish our presentation, you're going to see that it is actually extending its contact and its importance well beyond that horizontal rooftop surface. Dun, 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 dun. Don't want you to forget who is making this presentation today. It's none other than your friends at Firestone, because nobody does in fact cover you better. And the materials that we're going to be looking at today are in fact copyrighted materials. These are materials that we've developed specifically for this presentation, but these are all content from Firestone Building Products. And that's one thing that I like to bring forward, is that anything that we are showing and discussing in today's presentation, please have confidence in that it's not just something that we have randomly pulled. These are all examples that either I or my direct colleagues have had some immediate involvement with or some immediate connectivity to. And some of these pictures are pretty old, so some of those colleagues are no longer around, especially when we talk about asphalt. Key topics we're going to hit upon today. We're going to talk about the evolution of traditional systems into the more modern technologies. We're going to talk about why these things are more in demand. We're going to talk a little bit, touch briefly on some of the elements that the rooftop is now being asked to perform, some of the increased or improved or differentiated kinds of activities that are taking place there that for a long time had not gone on there. And we're going to talk about what the roof of tomorrow looks like, because it's already here today. Need I say more? But what's right with this picture? There are a lot of things that potentially could be right with this picture, right? First of all, this is not a Firestone Building Products roof. It was taken by a Firestone Building Products employee. No, what can we see here that's right? Slope. Somebody understood basic physics. I think that's a good start. What else is really present here? What do we see there? Not just flashing, but step flashing. Again, a basic understanding of how things work. Now, if anybody's environmentally conscious and sensitive to the environment around them, I think you'd be hard-pressed to say that this doesn't make ample use of local and regional materials. I'm guessing that most of this stuff came from less than a 500-kilometer radius. So you've met some lead credits somewhere along the way, I'm sure. It's a little bit in the dark there, but this is a retail operation. So it is, in fact, a commercial roof. There's no question about it. And you've got mixed use of materiality. What it's really meant to say is that even in the most primitive of circumstances, the need, the understanding, the provision of basic shelter is right here. It's right here in our heart. It's right here in our mind. We know this stuff. It's common sense. It's not rocket science. Now, there are a lot of elements of rocket science that come into play, no question about it. The advancement of the materials, the differentiation, but when it's all said and done, it goes back to a very fundamental idea or concept. When we talk about commercial roofing, it's pretty simple. There's really only three categories that we need to discuss. Bitumen-based systems, asphalt, coal tar pitch. You'll have to, I have to apologize in advance. I am not as clear on the availability of certain materials here in Canada as I am in the lower 48. But coal tar pitch is only available from one manufacturer and is not very well used or very much used anywhere in the States at this point. Is coal tar still something that you can find here in Canada? Yet arguably at one time maybe even now, it could have been considered the most sustainable roof that's there. I mean, I had the good fortune of working on a project in northern Indiana, where I'm coming from, cold weather climate, a lot of built up, a lot of bitumen up there, 75-year-old roof. The problem with it was that the person who had maintained it for 74 years prior passed away. I should say the 2 or 3 tenants. But therein lies part of the problem that we have with asphalts and bitumens. Not only are they constantly changing and organic, but the persons who are entrusted to take care of them are dwindling. The supply is no longer putting together a demand for persons to be able to do this. Single-ply roofing, the next category. The single-ply membranes. Real quick question, how many layers in a single-ply roof? How many layers in a single-ply membrane roof? It's not a trick question. There's one. That's why it's called single-ply. But the beauty of this advancement is that it is a single-ply. It's a single membrane that can be controlled. The only thing that you're really interacting with are the details, most particularly the seam, the flashings. But when it's all said and done, single-ply. And there's really only 2 forms of that. Thermoset, thermoplastic. When we talk about thermoset, that's the rubber membranes. What traditionally were the black rubber roofs. You're going to see that there's some variations on that theme now as well. Or the thermoplastics. And there's really only 2 categories for that as well. TPO, thermoplastic polyolefin, and PVC, polyvinyl chloride. That's it. And we'll see what differentiates those. But when it's all said and done, there's only 3 membranes in the single membrane category. Now, when we're talking about commercial roofing, there is one other category. And this kind of catches everything else. It's a bit of a mishmash. But metal roofing, particularly if we talk about architectural metal roofing, standing seam panels, etc., chosen often for its aesthetic. Or structural metal. You're going to find that oftentimes in pre-engineered buildings, where the wall assembly may be the same as what's used for the roofing assembly. And it may be integrally designed to the building to create a structural diaphragm, if you will, that the framing, the roof, and the wall all become one element. And it's engineered and it's manufactured in a facility and delivered to a job site. Or through-fastened, the old agricultural panels, the ones that were putting holes in an object that we would otherwise not want to put a hole into, correct? And then there's hot rubberized asphalt. I hesitate to even call that a roof. It's really more of a sealant, isn't it? Been around forever and a day. Heat up the kettles, pour it into the slurry, brush it out. Where has it made its biggest resurgence? Anybody seeing hot rubberized asphalt in a big way? Very big way. Vegetative roofing. American Hydrotech in the lower 48 particularly has become very adept at that type of a system. It's the most popular system in Washington, D.C., second most popular system in Chicago. Both of those have mandates for vegetative roofing. And this is a very quick and easy way to produce that substrate for a vegetative roof. We've done it for years. We call it plaza decks. As a matter of fact, if you visit any parking garage in downtown Toronto, I'm going to gather there's probably a lovely park above it. I know there's a skating rink above the one right out here by the chamber offices. I'm going to guess that that's probably got hot rubberized asphalt underneath everything that's happening in that park. And polyurethane foam, puff roofs for short. It's just as the name implies. It's a spray foam that goes right on top of whatever's up there. Encapsulates it all, and once you've put it on, you're never going to get it back off. So it better work. It's an incredibly good roof for the desert southwest, arid climate. I would be hesitant to promote it in any other environment. So when it's really all said and done, we've got 2 categories. Bitumens, single plies. And when we talk about the bitumens, there's really 2 families. The old built-up floor plies. More plies, more tries. That's right, more plies to get it right. They benefit from their inherent redundancy. They have a long history, 100 years or more. They use a lot of water-resistive materials, most often, though, relatively organic in nature. So from the time that they are put down, they begin the deterioration process at somewhat an accelerated rate. Now there are stabilizers, there are elements that go in there to cut down UV degradation and to help the amplification that water or moisture brings. But when it's all said and done, the technology, the methodology anyway, has really remained pretty much unchanged since its inception about 100 years ago. And then the modified bitumens, the 2-plies. We've taken something that was really aggressively involved, very sort of craftsman-driven, if you will, and drawn it down into 2 plies, 2 sheets, a base and a cap. Maybe a base, interply, and a cap if you need to really get some extra dimension or durability out of it. But the beauty of that is that those plies, that base and that cap, are manufactured. Consistent dimension, consistent thickness, predictable behavior. But really, when we talk about bitumen construction, it's either 4 or 2. That's about it. Build-up roof construction, just as the name implies. And here you can see, you've got your hot bitumen going down. You've got what are called ply felts. Those ply felts get embedded into that hot asphalt, that hot pitch. And then another layer, and then another layer, and then another layer. Each one staggered a quarter over each time. So that when you ultimately get done, no matter where you pierce it with the screwdriver, which invariably is going to end up going through a roof at some point, it will have gone through 4 plies of material. Inherent redundancy, that's its real strength. Very, very susceptible to changes in environment, from hot to cold, from age, from dry to moist. All of those have a fatiguing effect on that assembly. That redundancy becomes an absolute necessity. What do we do to protect it? Well, more often than not, we put aggregate on top of it. The aggregate creates a stepping surface, something that can take impact. But it also, maybe more importantly, blocks out some of the UV that might otherwise destroy that top layer. What do we see, though, downtown? What do we see in most cities? We see some sort of a paint, some sort of an application, aluminized. Look out of the building, anybody staying in a top floor of a hotel around here. Take a look at the roofs down below you. You may see a lot of silver roofs, an aluminized paint essentially, that's just protecting that top layer. But when it's all said and done, there's a lot of work that's going on. Why? Because the roof is being manufactured in place, in situ. The elements may have come on a truck, but each one was individually handed up onto the roof and included to essentially manufacture the roof right there on the top. There's recently been some other concerns about built-up roofs, particularly asphaltic roofs in general. Are there carcinogens involved? Because there's a tremendous amount of petroleum invested in this process. Is the bitumens that we're using in place of coal tar as carcinogenic, or even possibly more because of their chemical composition? You know, it's not a natural ingredient. To coal tar's benefit, at least a lot of it was organically being combusted or broken down. Is it maybe not carcinogenic, but is this high exposure, continued exposure to this going to be a problem? Because of off-gassing. As things deteriorate, as things break down, they begin to release whatever's within them, correct? Well, you think about this with a petroleum-based organic material being released into the environment. Somebody's working in that every day or working around that every day. Are there inherent risks there that it might not be present in other technologies that are out there? There's a lot that contributes to this. And I haven't even touched upon the availability of oil, the availability of the ingredients. I know this is true in Canada just as it is true in the United States. The asphalt, the bitumen that is manufactured for the roofing industry is from the bottom of the barrel. You know, when we use that term, it's from the bottom of the barrel, it literally is from the bottom of the barrel. But technology has advanced and is able to crack the molecules lower and lower in that to raise it to a higher percentage of use, a higher purpose, a better purpose. So whereas you could only get jet fuel and gasoline from the first third of the barrel, as it were, you can now crack that on down and get that from the lower half, the lower 3/4 of the barrel. So all of those other uses that are in between that go into synthetic materials and other composite elements, and more importantly, road paving is getting squeezed. The element that you can take from that is now lower and lower and smaller in that barrel. And more often than not, because there are many, many other alternatives when you talk about roofing, it's going to roads as opposed to roofing asphalt. Okay? So there's some real rationale here as to why this is happening. Well, to the rescue comes the manufacturing world with mod bits, modified bitumen. Simply stated, there's two kinds. There's SBS and there's APP. How many kinds are there in Canada? There's one, SBS. The reason I know that, I work for Firestone Building Products. I get to see how much we sell of everything. And we sell all of it, by the way. That's one of the things that gives us, I think, and gives Firestone Building Products a unique opportunity to be in this position today, is that we are the manufacturer of all forms of commercial roofing. We're number 1 or number 2 in the United States, and we rank very highly, I think, in single-ply categories here in Canada for sure. So we can see all of it. Anybody want to tell me how many rolls of APP or plastic modified bitumen we shipped to Canada last year? Just a random number. 3,000? 15,000? That's right, 0. 0. And it actually comes as somewhat of a surprise, because it is a northern climate, I get that. And APP doesn't really necessarily translate well because it's plastic. Plastic wants to harden. SBS responds favorably well. It's rubberized. It has a higher tolerance for cold temperatures, right? But the single most popular roofing in New York City, which is arguably a cold weather climate, is APP. APP torch down, to be exact. Why? Because you only have to have a truck and a torch to be in business, right? It's pretty simple. Well, I'm sorry, New York City, torch, truck, and a driver. Nobody pays for staging. So meter-wide roll, they can just toss off however many rolls they need. And they roof from 6 o'clock at night till 6 o'clock in the morning, and then they're gone again. Well, insurance people, attorneys love torch-down roofing. Why? It's business. It's business. It's built in. It's like the doctor being the undertaker. You can imagine open flames in a large concentrated metropolitan area. Not really very favorable for that environment, but attorneys and lawyers can make quite a bit of money prosecuting those things. So, New York City says, no more AP torch down. None. Against the code. Anybody want to tell me what the most popular roofing in New York City is now? Single ply, right? No, APP torch down. Because they left a little caveat. That's only in brand new building construction. I get to see all the roofs that come through for warranties and application within the organization. And it's not uncommon in New York City on the island of Manhattan to see a project come by, 80% restoration and re-improvement on an address, and then 2 weeks later, a 20% restoration and re-improvement on that same address. Because if you put down the roof that was there before, it's grandfathered in. It's amazing how many new roofs are just repair jobs in New York City. It is manufactured in a controlled environment. That does make it one step above, in some ways, the built-up roofing market. There's no question about it. And you can see that it goes down pretty simple. Base layer and a cap layer. Offset it by a half. Start with a half sheet on the top cap. It can go down as a torch down. It can go down in what's called cold apply, where you're basically mopping it out, or brushing it out. It can also go down as a hot applied, at least with the SBS. You see that going down as well. You can only hot mop the SBS, by the way. But you can see that we're still largely manufacturing the roof on the roof. We're having to perform all of that right there. By the way, when you have something like this, when you're working with that, you need 2 crews. You need a boot crew and a tennis shoe crew, and I'll explain that in a few. However, because of the advent of modified bitumens or the use of modified bitumens, you can also get those in bright white caps. So if you are trying to meet a higher initiative, a LEED or a green globe, or just want that higher reflectivity for whatever reason that you're trying to achieve that, there are bright white caps out there available to you. There's no question about it. But by and large, this is still the most popular way for modified bitumens to go down, APP or SBS. Matter of fact, SBS is of the two, the more growing or more has a higher growth potential. But the bottom line is it's still open flames. You've got that open torch. What does this do? This is called a dragon wagon, by the way, for obvious reasons. You now no longer have one man or woman up there with a torch swinging it back and forth. You've got literally an entire explosive device spewing out 5 or 6 jets of flame on top of the roof. What's the inherent problem here? Control. Control after the fact, though. Quite frankly, it is not so much during the time of installation, because you're seeing that, you're walking, you're doing your thing, right? It's good. But at the end of the day, what else has been affected that wasn't apparent when you were there during the working hours? I can give you examples from right here in Canada itself. This is the Goodwill out on White Oak Road. Fire officials say it appears a portion of the roof was being repaired when sparks from a torch somehow got inside the building, igniting a number of boxes. That's called incidental damage, by the way. The roofer and the roofing manufacturer they're essentially going to be held harmless, because they can't be held harmful, or they can't be held responsible for anything inside the building. And it'll go through a lot of litigation. It'll be fought, and there'll be a lot of battles back and forth. It'll be in the paper a few times, but when it's all said and done, it's the owner who's going to take the onus for this in their insurance. How about the new Amazon data center? This isn't limited to old re-roofs. It was a fire on the roof involving the roof, roofing materials and construction materials. Workers who were on the roof when the fire broke out were able to extricate themselves safely. Nice big word, isn't it? It means get the bejesus out, right? Said Mary McGuire. So they got out unscathed. It was a new construction. Nothing was in it yet. If that had been full of merchandise, or more importantly, full of people, and that's tragically where this thing ultimately ends up. Fire codes do end up getting changed before. This was Ontario's fire marshal. By the way, this was just last year, and unfortunately, tragically, this fire smoldered for about 40 minutes before anybody even knew about it, because it was in between the roof and the ceiling. It was not exposed. And the valiant men who showed up to fight that fire, 2 of them lost their lives. It was not intentional. It was not something that anybody would have ever thought could have happened, but it happens a lot. It happens a lot. Asphaltic roofs, bitumen roofs, have a large part to contribute to that. So at the very least, exercising a high degree of caution when doing these types of systems is a necessity. So what are our key takeaways? Well, it has been performing well for many, many years. There are a tremendous number of installation options. You can say that either as a positive or a negative, because when there's so many ways to do something, there's rarely any one good way to do it, quite frankly. Where I'm coming from in Indiana, we have a horticulturalist, and people were having a problem with moles in their gardens and in their lawns, and his name is Dick Crum. Said, Dick, I have a mole problem in my yard. What can I do to take care of it? He goes, well, there's about 50 ways you can do it, which was another way of saying there's no way to do it. There's no good way to do it. They do capitalize on their redundancy. There's no question. More applies, more tries. It's a little tongue-in-cheek, but it does build in some resiliency. But it has to be there because it's really sort of compensating for degradation. Thermal shock, hot and cold, water, UV, all those things are constantly barraging what is largely an organic element. And they have adapted to today's world. We've seen that. Bright white. It's the first one I can think of right away. But they're often complex, and we've seen when we talk about the torch down, we talk about the fire, etc., they can become unwieldy. And there's a dwindling labor pool that, whether they have the skill or not, don't have the desire to do it. It is very difficult. Actually, if anybody here has a son or daughter who would be interested in doing hot mop roofing during the summers, I suspect you could see me or any of my colleagues, and we could arrange work for them that would definitely prevent them or make them decide not to go to university, because they'd be so busy all the time. Of course, they'll be worn out and broken down after a certain period, but get in early, live hard. Bottom line is, when we look at the world, and that's not necessarily in your neighborhood. I understand in London, Ontario, it's a growing system. I understand in outside Saskatoon that it's a growing system. But by and large, when we look at the broader spectrum, when we look at everywhere else, and including most of Canada, bitumen systems are declining in their use. It's that simple. Which brings me to the viable alternative, maybe the preferred alternative. But I have to let you as professionals determine that. You have to become knowledgeable, you have to become comfortable, you have to gain that understanding of whether or not this makes sense for you. But at least from my own perspective, I think that you have to give it a fair shake. You have to really look at what these alternatives offer you, but more importantly, what do they offer to the ownership of these roofs? Because we specify them, we sell them, we install them, and then we're at the next roof. Somebody has to own this thing, and it's going to be that person that has that building for the next 10, 15, 20, 30, or in the case of school systems, hospitals, 40 or 50 years maybe. So think about that. As I mentioned, when we talk about single plies, there's only two types: Thermoset, thermoplastic. And we talk about Thermoset, there's only one, EPDM. Talk about thermoplastic, there's only two, TPO and PVC. And you can see some of the things that really define these. EPDM, it's a permanently formed membrane. It's vulcanized. It's rubber. Now, it doesn't come from a rubber tree plant, but it mimics that. Okay? Just like tires. Tires do not come from rubber tree plants, but they mimic that. The reason I know that they don't come from those plants is because the company I work for, Firestone Building Products, has a key name in it. Does anybody know what might make us uniquely qualified to be in the rubber business? Only about 125 years of tire manufacturing. Harvey Firestone manufactured those tires over 100 years ago. First started out with natural rubber. What color were they? Cream. Unattended rubber from a rubber tree plant, organic, is cream colored when it's coagulated, when it's made into gum. Adding carbon black, granular powdery ingredient that goes into that goo, is what gives it its tenacity, gives it its UV protection, gives it its longevity against wear. Before Harvey Firestone, tires were white, and now they're black. We like to say it's because he wanted to see a better looking car at the Indy 500 track. I'll buy that. I'm from Indianapolis. I like anything racing. Doberman's on roller skates. I'm there. Once it's cured, it's what it will be. And you weld the seams, you attach the seams by using an adhesive. And we'll see what those technologies have meant. It can easily be repaired and maintained. High degree of puncture resistance, high degree of tenacity, but you can identify exactly where it is in one small patch or a tune-up, or dealing with those very limited number of elements allows you to maintain these for years and years to come. TPO and PVC, plastics. We'll talk about those first. It is, in fact, the largest product category worldwide at this point. Matter of fact, TPOs make up the largest percentage of that. We'll see some of this in a moment. But again, there's only two types, TPO and PVC. They use heat to weld the seams. They meld the two membranes side by side together, and the two become one. No adhesives per se. Heat, hot air, not open flame. Hot air is what's used to weld those together. And they're most often distinguished because they're white. That's what they primarily come in. Now, you can get tan, you can get gray. There are manufacturers in the PVC market that make dark blue, dark green, really any color that you would want if you're willing to pay for it. But by and large, they're recognized because of their white membrane or white outward appearance. Variety of widths. More often than not, they've been mechanically fastened. We'll see why that's important in a minute. And they always have to be fabric reinforced. There has to be some sort of a reinforcement in the membrane itself in order for it to work. We saw that it didn't work early in the 1980s. PVCs came over from Europe. They were dark in color. Those things heat up. They had no reinforcement. There was nothing there to keep it intact. We had things that were called shatters. Literally, they would shatter. It looked like a dry creek bed on top of the roof when it was done. I had the good fortune of being inside of a building when that happened one time. It sounded like ice splitting in the spring. It's when you know you got to pull the hut back off of the... My friends in Thunder Bay know what I'm talking about. So, in any regard, the difference is PVC and TPO are both plastic, but TPO is what it is. The ingredients that go into that are alloyed together to make it soft and pliable by design. Polyvinyl chloride, PVC, has to have a plasticizer. Without the plasticizer, without the softening agent, PVC becomes what it was intended or what it wanted to be. Schedule 40 piping. Think about it. Rigid PVC piping, very, very popular, used in a lot. No plasticizer. The plasticizer is the ingredient that makes it pliable. But in sort of simple terms, it's what's agitating that compound. Could be liquid, could be actually what they call a dry plasticizer. But in order for the dry plasticizer to go in, it still needs a liquid to embed it. And from the time that it's manufactured, it is now fighting and really having an inner struggle with itself, molecularly or chemically, because it wants to evacuate. The plasticizer does not want to be in the material. Keeps it pliable, but it wants to evacuate. That scrim that's in there does a lot to help it get purchase on something to stay in there. Okay? How can you tell when you've had plasticizer evacuate from a PVC roof? Pretty simple. It smells like a freshly opened shower curtain. So if you go up on a roof and you smell that very acrid, very bleachy, antiseptic smell, that you know what I'm talking about, the plasticizer is left. The other way to tell is if your roof was at one time kind of dingy and gray over time and use and age, and it suddenly becomes bright white again, you know that the plasticizer is essentially evacuated. TPO outpaces PVC mostly because of cost, when it's all said and done. I think there's a lot of other very positive reasons TPO does, but when it's all said and done, when choosing between the thermoplastics, TPO generally wins because of cost. They are less costly than PVC manufactured roofs. Less involved. I'm going to spend a little more time, though, talking about thermosets. Thermosets, one category, EPDM. EPDM rubber, synthetic rubber. Common thicknesses, commensurate with what we normally understand, 45, 60, 90 mil. You're going to find that this is true across all stations, across all manufacturers. There might be a little variance here and there based on application. Pond liners are generally only 38 mil or 35 mil, but that's not roofing. We're talking about roofing today. 60 mil, no question, the most popular. And I find very little cause, you should find very little cause, to really be considering a 45 mil. The greatest use, the highest use I find for the 45 mil membranes at this point, just based on application, is when you want to provide a sacrificial layer, a separate loose laid layer to protect the main body of the roof. Works very, very well for that kind of an application.
So even in an inverted roof?
Even in an inverted roof. Part of the reason is because of puncture tenacity. I understand that an inverted roof might in fact be considered a protected membrane, quite frankly, because you're putting some sort of a ballast over the top of that, oftentimes an insulated composite ballast, maybe a concrete pad within. But the point is that things will find their way down to that roof surface. Things will be underneath those PEDs as they're going down, et cetera, et cetera. And any kind of traffic, any kind of impact on that suddenly makes that have a higher potential for puncture. And with the 60 mil, when you see the puncture resistance and the relatively little additional costs involved with it, it's very cost-effective insurance, if you will, or reassurance in the application. They can be reinforced or non-reinforced. There's reasons why you would choose either one. I would say more often than not, what I see is I see non-reinforced bodies or fields with reinforced perimeters, parapets, curbs, flashing details, but not always. They do have taped seams. All EPDMs, all thermosets use a taped seam of some sort. We'll see what that means, because that used to be a bit of an issue, right? And they primarily are black, but you're going to find that there's also white membranes as well. They use seam tape. Why is that important? Because for a long time with single plies, the Achilles, if you will, of the single ply membrane was the seaming. How do you get it consistent? Well, that element has been removed with seam tape. Seam tapes themselves are engineered not only to be much more predictable and precise in their application, but the adhesives are actually designed to gain greater tenacity over time. All adhesives have to cure, right? No question about it. So when we talk about EPDM, as that tape seam cures, it actually gains higher and greater purchase on the membrane. Now you will see a small bead of sealant run along the cut edge of the membrane oftentimes. What is that really doing? It's really only necessary to be there for, let's say, the first 2 to 3 months of the application, because it's protecting the seam while it cures. So sometimes you'll go and you'll see the sealant at that seam edge, at that cut edge, and it may start to look like it's degrading. Rest assured, you do not have a problem. You do not have a problem, because it's most often there only to protect that major seam as it cures out. Once it's cured out, no issue. Cleaners and primers. Variety of those available, and we'll talk a little bit more of those as we get into that. But and some way to apply it. These are really the primary contents of what you have to have a single ply EPDM roof. That's it. No kettles, no pumps, machinery. Yes, there are some buckets that are always 5 gallons, and we'll see in other ways those become important. But the beauty of it is all the accessories. All of these single-ply systems, and most particularly when we talk EPDM, have pre-manufactured, pre-engineered accessories. The boots, the inside and outside corners, the fasteners that might be needed as a supplemental application when you're not fully adhering everything or you're tying off at the perimeter. And then all of the sealants and or adhesives then are also especially designed, not just for the material itself, but also the region that the material is being performed in, which is becoming more and more of an issue every day. Thank you very much. The question is, what is the life expectancy of an EPDM roof? Well, we don't know yet. What we can say with absolute certainty is that 35 years has been easily achieved, and we're heading towards 40. As a matter of fact, Firestone Building Products this year is celebrating its 35th year in the EPDM roofing business. And the first roof that we put on is still operational and functional in Wisconsin. Not exactly a mild climate environment. Best guessed estimates, though, are that the membranes themselves have a lifespan that's going to go well beyond 50, maybe 60 years. Who knows? Who knows? It's always been the case, and this is true of any of these systems, roofing systems. It's not necessarily the base material or the core material. It's the application, the details that have gone into it, the seaming, the flashing, those ingredients that make it a comprehensive system that have been more prone to failure than the materials themselves. So right now, the the lifespan of the material itself is somewhat indefinite, quite frankly. Lot of things that go into it. How easy is it to put these things together, though, at this point? Well, it's pretty easy because you say mark the membrane, but oftentimes we already know what that mark is going to be like. You do have to scrub it or clean it because there's talc on an EPDM membrane when it's manufactured so that it doesn't grab onto itself at the time that it's being vulcanized. But then that talc, you want to make sure that that's washed away so that you've got a dry, tacky type of a surface. Applying the tape in over the top of the primer, a bit of braying of it, a little bit of using a roller to make sure that you've got good purchase on the material itself, then lapping in the adjacent material and pulling out the release liner of the tape, and then braying over the top of it, and then you're essentially done. As I said, maybe go back in with a beaded sealant if that's what's so specified or called for along that cut edge, but otherwise, that's all there really is to putting together one of those seams. And we know that we have a life expectancy on that seam that can at least be warranted for 30 years or up to 30 years. Now, all warranties, I don't care what type of system, what manufacturer you're talking about, they all have their stipulations and their values, et cetera, et cetera. And truthfully, the materials that go into an EPDM roof, a TPO roof, or even an asphaltic roof are not different from a 10-year warranty to a 30-year warranty. What's different is the attention or requirement of how it's detailed. More often than not, that's what makes the difference. With EPDM, the one primary sustaining difference to get from that 20 mark to that 30 mark is to go to a 90 mil membrane versus a 60 mil membrane. Okay? To get from that 15 mark to the 20 mark with a comparable 60 mil membrane is just the detailing. Maybe double lapping a seam or double lapping something that you know is going to be in a water-soaked area. Not talking about the backsides of parapets and flashings like that, but someplace that you know that you're going to have a certain amount of lingering water, let's say. That might require a tape over. But that's all there is to it. They've been improving, and they've been in use in all geographic areas for well over 30 years. All of the historic performance issues have been resolved. Some people used to say, well, that rubber roof, it shrinks. Well, it didn't really shrink. What was happening is that persons were putting it out with too much tension to begin with, and so it was just essentially returning to its natural shape. What we've learned over time is that when you put it out there, you need to, like anything, let it relax into place a bit, right? And the way that they were being tied off at the perimeter, it used to be they were just shooting it down with a board and some cap screws, and now there is what's called a base tie-in or a relief strip that you put into the membrane or into the roof surface at the corner, at the perimeter, that can take the tension of the horizontal so that anything that goes vertical, up and over parapets and up and over curbs, is essentially in a non-stressed fashion. You can simply adhere that or affix that to the backside of the curb of the parapet, and it's not being affected by what's happening in the horizontal plane of the membrane. So those are the things that we've learned and that have been resolved over time. EPDM has the greatest variety of membrane options available to it. There's no question about that, and the greatest variety of installation options available to it as well. And when it's all said and done, these have the highest warranty available of any of the systems that are out there. You have to go to special measures sometimes to get extended warranties in asphalt for certain. You have to go to special measures to get extended warranties in thermoplastics because the plastics and the way that you weld it are significantly different. So it's sometimes more easy to achieve extended warranties or longer warranties on EPDM roofs. When we talk about roofing systems, we're really talking oftentimes about how they're attached. Yes, we talk about their basic composition. It's an asphalt roof. It's a TPO roof. It's an EPDM roof. But maybe more important, and certainly very important to its long-term performance, is how is it being affixed to the building? How does it stay in place? Or how is it going to perform under the dynamics that affect a roof? Because you not only have wind scour and rain, the very obvious ones, but you also have uplift pressure. You have pressure that's happening inside the building. That's dramatically different from a big warehouse with overhead doors versus, say, a speculative office building with a relatively small footprint. And those dynamics are happening from under the roof. They're pressuring it, pushing it up on it. What's the single most destructive force on a roof, though? Bar none. Gale force winds, hurricanes, tornadoes, sun, UV? No. Good answer, though. The most destructive force, bar none. Mechanical contractor. No question. Rooftop traffic from the mechanical contractor. I'm picking them. Any mechanical contractors here today? Good, because we won't have to lynch you. No. That foot-top traffic, and why do I pick on the mechanical contractor? Because if they're up there servicing rooftop units, all rooftop units have filters on them. All those covers on those units have 36 tech screws that go around the perimeter of that. After the first filter change, how many tech screws go back in? 2, upper left, upper right. Where do the remaining 34 tech screws find themselves? That's right there on the membrane of the roof, underfoot of the contractor who just serviced the filter. Makes a very, very good argument for having walkway pads around your equipment. 2 things about walkway pads, by the way. Best place to put them? Around serviceable equipment. No question. Second thing, architects, stop drawing them orthogonal to match the beauty of your building. Look at the roof plan. Rooftop unit there, scuttle here, direct line. Don't go up north 30 meters, over to the right 20 meters to get to it. Surest way not to get somebody to walk in where you want is show them where to walk. Just look at the footpaths on any university campus. But anyway, I digress, which I do a lot. Oldest and longest sustaining ballasted membranes. It's basically where you're just putting the membrane underfoot with something to weight it down. Concrete pads, more often not, river wash gravel. Could still be considered a environmentally sensitive roof. I mean, you're adding mass. The color is relatively light. That thermal density actually qualifies it in the States for what's called Title 24, the highest standard established by the state of California. And they come out with the highest standards to be met or not met by everybody out there. But just be aware that they have a lot of weight involved with them. These put increased weight on the rooftop building. Where do I see these actually most popularly employed? Single-story grammar schools, K through 12 kind of work, no question. And if you do employ this, the key word here is ballasted. There's no mechanical attachment. There's no adhesive to make it fully adhered. It must float, and the elements that are under it must float. The insulation is loose laid. The membrane is loose laid, and we're just weighting it down. Beautiful thing, they can do very, very large panels because they're uninterrupted, just seam to seam to seam. It is sometimes a little bit difficult to find the leaks, as you might imagine. And this is what it looks like going down. Protection mat is always a good choice. It's not absolute, but it is a good choice. And you can see that the precision with which it's laid. Mechanically attached. I really reserve that for the thermoplastics. That's where it has its highest degree of popularity. It uses screws and or Batbars. You're kind of limited to narrower panels, or at least narrower widths to think about when you're putting it down, because more often than not you're going down in the seam itself. And so that attachment point has to work to be able to withstand those uplift pressures from behind there. So you're talking about 10 feet, 8 feet, 5 feet. Problem is it goes off module. If things are manufactured in 10 and 12, that's great. And if you can get your seams to be 10 and 12 feet apart, that's great. But most of the standardized insurance protocols, most of the standardized uplift resistance that are out there, go out to SIGGers. You can see this for yourself. They're going to require you to have a seam every 8 feet or every 6 feet or something like that, and it's going to go off module. It's going to cause you some problems to get what I call efficiency out of the materials. And it's almost always a linear attachment as well. It can allow for flutter. These things get noisy. And in colder climates, where you haven't taken necessary precautions with air barrier infiltration or insulation, you can get flutter. But more importantly, you can get frost because there's a certain amount of cavitation that's going to happen underneath a mechanically attached membrane. When that pressure's in there, it may only open it up a small millimeters or centimeters a bit, but that's just enough to possibly have moisture form beneath the bottom side of the membrane and the top side of the insulation. And because these do not heat up like a black body membrane, they stay ambient temperature almost all the time. That means you're going to have that frost in underneath your roofing membrane and on top of your insulation, then eventually permeating down into that. I don't want to be as dramatic as calling it permafrost, but effectively that's kind of what you're starting to create potentially. Like I say, it's good because it's cheap and it's easy, right? Here you can see a person steadily at work at it. Definitely a Canadian roofer in the middle of January, right? Wearing shorts and all this necessary safety equipment. There is an alternative when you are talking about doing mechanically attached induction welded. This is where you are able to attach the entirety of the system down to the substrate, the deck, and the plates themselves, the fasteners, have the constituent TPO already on them. You come back and you magnetically or heat welding it to the backside of the membrane. So what does that mean? Well, it means that your membrane goes down over the top of this. You can weld it wherever the seam or the sheet ends, as you would want, and you're actually attaching it from the back side with this welder. And then you lace, as you hit each one of those, you're hitting it for about 30 seconds. Then you come back with this weighted, it's almost like a coffee can full of concrete, basically, with a magnet in it. And it just further makes sure that you get that contact and you're going hand over fist, just walking right down the rows to do that. Another way that you can actually attach the thermoplastics is with asphalt. So you can encapsulate an existing bitumen roof with a TPO membrane. Use what's called fleece back. It has fleece on it, and it also has an edge that is not got the fleece on it so that you can weld it. You need to get your roof predominantly very, very clean. It needs to be scoured of all aggregate, and it needs to be able to accept the bitumen so that the membrane itself can get purchased on what's essentially the hook or the loop side of Velcro, the fuzzy side of Velcro, and that will seep up into that. You can also do it with adhesive, and that's actually a cleaner and more effective mechanism to do that, quite frankly. But you get a fully adhered roof, and you're encapsulating what is otherwise a dry and performing roof. I hesitate to recommend it because if you have moisture that's already entrained into the roof or other issues, you're now creating a greater hazard, okay, or greater sense of, or chance of degradation. Boot crew and tennis shoe crew, obvious reasons. This person's in the mud or in the tar. This person's out on top watching it. Need a third person. This would be the son or the daughter looking for that summer job. We call it the best teen boy. Not saying to be sexist, it's just alliteration. Best teen boy goes around and cleans all the black splotches off of the white roof so that when the owner sees it for the first time, it looks clean. They use best teen. Fully adhered. This is without a doubt the best way to do this particular system. This is the way to go about working with EPDM, certainly, but it generally will provide you with the highest degree of surety in your roofing system is to go to fully adhered types of systems. Traditionally, could be mopped out or sprayed out to put the adhesive down, and when I say the adhesive, it's essentially sort of a dry tack primer or a dry tack adhesive. You're putting it out moist, it flashes off, gains a certain amount of dryness, and you're doing the same thing to the back side of the membrane simultaneously, and then when they're both dry, flopping it in. And you've got a dry tack continuity. And because you're doing it over and broadcasting it over the entirety of the body of the roof, you know that you've got a high degree of attachment, even if maybe a little pocket here, you know, a small pocket here or there didn't actually get hit, it will, in fact, have a broadcast attachment to it that's going to be complete and continuous. And if you go to the next level of that and make sure that you roll it out, bray it out when you're done, you're absolutely going to get that contact. Okay? Love this. We're talking about 5-gallon jugs or 5-gallon buckets. This is called the Better Spreader. It's basically a roller cart with tubes that have been cut off at a high angle, like a poke, like a oversized needle, hypodermic needle kind of thing. But they're on this carrier that basically you just drop the adhesive onto the carrier, and it drops it out onto this roller that then just drag it across the roof and roll it. Greatest, simple, intuitive invention I think there is. And this is pretty basic stuff. You know, going back to my architecture days, I mean, those things that look complex generally are complex. And those things that look the most simple generally work the best. Now, there are other things you might be achieving, an aesthetic or something, but when it comes to commercial roofs, I think those things that are most simple, the things that are most easily understood and engineered are going to ultimately work the best. You know, all things being equal, Occam's razor, right? So, challenges for EPDM, for thermosets, for adhesive roofs in general has always been sort of temperature, but this is what a beautifully taught, black-bodied EPDM fully adhered looks like. I say reinforced and non-reinforced because it's going to outwardly have pretty much the same appearance. And the reasons that you would choose that might be twofold. One reason you would choose a reinforced is if you have to reach a certain insurance specification. FM specification is the big one. Factory Mutual, global insurance company out there. Almost all of theirs are going to require a scrim in it. Why? Not because it's giving you better service necessarily, but because it was able to be destroyed. A non-reinforced membrane, how do I put this? We cannot test a non-reinforced membrane and destroy it. It has 300% elasticity and goes right back to what it was like. We can't produce equipment to put enough pressure on it to actually destroy it. But we can produce enough pressure to destroy the scrim itself, which will then tear the membrane at the same time. So really the reinforcement is mostly to reach a testing achievement that can be quantified by the insurance industry. I know, crazy stuff, right? The other great thing about a reinforcement, though, impact resistance. Screwdrivers, foot traffic, embedded stones, et cetera, that reinforcement will give you greater puncture resistance, quite obviously, particularly from sharp objects, which are the only real issue when we talk about a single-ply membrane. It's not the boulders, it's not the big things, it's the little things, the sharp things that cause a problem. And how many sharp things do you really have on the roof, or should you have on the roof to begin with? But it's just something to be aware of. And here you can see it going down with the pre-taped seams. It's also available in white. Matter of fact, it's a very, very popular choice. We see this used a lot into the Pacific Northwest part of the country in the United States. I'm also seeing quite a bit of it being used now throughout the Middle West as an alternative to TPO. This is what I really wanted to get to, though. Times they are a-changing, and they are changing quick and dramatically. Self-adhering membranes. Now, frankly, they've been around for quite some time. They've been around for about 10, 12 years probably. But they were all based on hot melt glue, for lack of a better term. And they required that you put a primer down on the roof so that the adhesive that was on the membrane could get attachment to that roof. And it still had to be 40 degrees and rising, 6+ degrees and rising, right? Trying to do my Celsius to Fahrenheit equations. I'll try to do them quickly. So, but it still required, it worked, but it worked only in those situations where it was, you know, sunny and warm. Other times it was very temperamental to try to get it to affix and stay well. Worked, but not maybe that great. Firestone Building Products has done a lot to advance that. With the Firestone Rubber Guard EPDM SA, with what we call secure bond technology, we've overcome that issue. Why? Well, because now all you do is kick it out, pull away the liner, finish the seams, and walk away. No primer on the deck, No additional adhesive applied to the material. Just a simple release liner. You can see right there, there's a little bit brighter white line in there. That's because the release liner is in two halves. The way that they lay this down is you kick it out, you release half of it, tack it into place, then release the other half and flop it in. Okay? You get the idea there? The principle that's at work? You can kind of see how this is going on there. Then come back and bray it. Here's the thing. We're already seeing folks, men and women out in the field, who are kicking the whole thing out. They got one person up at the head of the membrane, standing on it, if you will, or they cut away a little bit to just tack the leading edge. And then there's one person kicking the roll out while two persons are walking behind them, pulling it out simultaneously at a 45-degree angle. The liner, pulling it out. So they're laying it all in one pass. It gains purchase on the substrate when it has pressure put on it, not just by laying there. So the pressure is what actually gets it to take point. Okay? It's what gets it to attach. And, oops, turn that off. And once you've rolled it in, it's there. It stays. No primer. Oh! Most important thing, although my folks in Thunder Bay told me why it's not that big a deal. -6 and rising. 20 degrees Fahrenheit, -6 Celsius and rising. Every other roofing technology requires 40 degrees, 7 degrees and more. 20 degrees and rising, no primer, directly onto insulate. The only thing I would say is if you're putting it directly onto concrete, which I'm not sure why you necessarily would, maybe a lightweight concrete or something, you'd want to seal that concrete. But any of the other conventional roofing materials that are out there, direct application. And this stuff is just absolutely amazing. It gains more strength the colder it gets. It's amazing, amazing stuff. Been using it in the U.S. now since the beginning of this year. It'll be available in Canada going into 2016. I think this, I've been around the roofing stuff as an architect now with Firestone. I've been around this stuff for a little over 25 years. This is the first time I've seen something that I think is truly revolutionary. I mean, there's been a lot of advancements in it, but this is really going to change things a lot with regard to application. Why isn't it a big deal in Thunder Bay? Well, because as somebody explained to me, -6 and rising, well, the ponds are pretty well frozen at that point. We're already fishing. Don't want to get in the way of that. And I understand there's a lot of regions in Canada where you tent over the building to do the roofing. I mean, that's a common occurrence. Well, I can't do anything to say, well, it's going to be better that way, but what I can say is it's going to extend that roofing season significantly and extend the opportunity to have a fully adhered roof immeasurably. Just to show you how this trend is going, this is what we've seen happen over the last 5 years. Whereas asphaltic roofs made over a quarter of the market that was out there, just in the last 5 years alone, it's now almost 80% single-ply membranes, and that's in 5 years. That may not seem like much, but that's because we're putting on how many roofs in our neighborhood. Expand your mind, expand the concept, expand the dimension that you're working in. Worldwide, this is huge. This is absolutely huge. So I think you're going to see this continue to be the trend. As the resources and materials that are available to create the modified bitumens, to create the built-up roofs, are dwindling further and further, the inherent risks and costs associated with doing asphaltic roof continue to change and increase, and the age of the workforce and the workforce willing to step in and do this stuff. I mean, I'm not saying that we are not a people who are immune to hard work, but I don't know. I'm watching Netflix a lot more than I'm going to a video. There aren't even video stores to go to anymore. So, I mean, everything is coming home. Everything is becoming much more immediate, much more convenient. Single-ply membrane roofing, I think, represents a sort of a coherent transition that is coincidental with that attitude. I'm going to talk a little bit about insulation. What are we looking at here? That's right, frosted Pop-Tarts, lovely breakfast treat. No, what we're looking at is the inappropriate way to approach insulation. For a long time, this is the way that insulation was performed. A layer, enough to maybe keep some of the heat in during the winter, keep it sort of cool in the summer. The single most important thing that you can do with any installation of insulation project, offset and stagger, 2 layers in place of 1. That's what it looks like. Now, the infiltration that allows that hot or that cold to transfer back and forth is limited to essentially a pinpoint where there might be a coincidental point where the seam is at. But otherwise, you've effectively magnified the ability for your air and vapor barrier to do its work. As a matter of fact, in some municipalities, certainly in the lower 48, this can qualify in a fully adhered system as your air and vapor retardation without a supplemental membrane. That's changing too. You guys are already aware of it. You've been putting that membrane on for a long time. We're just now getting around to it down south. When we choose the insulation, there's really 4 types that are out there that make up all the roofing insulation. Polyiso dominates that market. Why? Well, low threshold of temperature, operational temperature, compatibility with a high degree of solvents and adhesives, certainly a much more favorable pass rate when it comes to the, FM 4450. There's also the UL, the fire tests in simple terms. Highest R per inch, that alone makes it the most popular. Because polyiso basically acts or behaves like aged wood. It doesn't really burn, it chars. Polystyrenes, XPS, EPS. EPS is the stuff that you support boat docks with. But XPS, sometimes used for very low threshold for melting, and so you have to always put some sort of thermal barrier, some sort of thermal break, some sort of a non-combustible sheet underneath the insulation before you can put the insulation on the building and then put the roofing membrane on it. Polyiso does not have that same level of requirement. Very popular these days, mineral wool fiber. Roxol is the big company right out of Canada here. But the downside is very, very low R value in relative terms. It's very porous. It's somewhat soft, so it doesn't give you that solid substrate. So if you can be sure that you only have lightweight mechanical contractors on your roof, maybe that will help. Just trying to help out the other guys. But a tremendous amount of embodied energy to make that. Superheated to 1500 degrees, spun like cotton candy. But that's a tremendous amount of energy that goes into making it. Now, it's very considered environmentally responsible once it's in place, but what it takes to get there is another story. You have another option also when it comes to the cover boards. For a long time, it was always the wood cover, wood fiber. That was very, very popular, certainly with the built-ups and the modified bitumens, sort of the tradition. And then along came the overnight success, glass fiber reinforced gypsum board, Dens for most of us, or Secure Rock is another name that's out there. Various manufacturers have it, but you know it's much more highly impact resistant. 1/4 inch seems to be the most popular. But I encourage you to take a look at, particularly when we talk about in conjunction with the single ply membranes, high density polyiso. Derivation of the same theme. Polyiso in and by itself is either 20, 25 pounds. This has a much higher density, but it's still the same material. So the value of that is that at a 1/2 inch, you can get an additional 2.5 R into that roof system. And R value is king these days when we're talking about building up that roof. 20 is the nominal starting point. Probably down here in Toronto, I think it's maybe already 25 R. I know upper parts of the states, Minnesota, Minneapolis, it's 35 R starting. So, that equates to depth. That equates to thickness of the roof system, right? So if you can get 2.5 R out of the cover board, which is an incredibly important practice to have, versus the dense stuff, which is only giving you a 1/4 R, and even then, most architects I know don't really calculate it into the value. You can't really, it's not really kind of fair to do it. It's pretty nominal. So in any regard, HD polyiso gives you that opportunity. Air, and you'll notice that I respelled the word vapor so that it can be understood. I don't know if anybody caught it earlier, but I had CLOUR for color. Is that trite? Is that just pandering? Good, good, because I like to connect with the audience. In any regard, we're only now beginning to see that in the lower 48. You have always had it required here throughout Canada. I do not want to get into building physics today particularly, but I will tell you that Firestone Building Products' commitment is to building envelope. That's where we are going. That's what, quite frankly, over the course of the last year, I've done significantly more presentations on building envelope than I have on commercial roofing, and that whole idea of continuity. And it's largely being driven in the States by the International Energy Code and becoming inherent down there. You've been doing it forever anyway. But to give you an idea of an opportunity within that roofing system that you may or may not be employing is something that is self-healing membrane. Because even if you're doing a fully adhered system, you may still have errant fasteners that are invested or involved with that, or areas that do have mechanical fastening. One of the strategies that I always used in practice, and I still promote it heavily, is mechanically attaching the first layer of insulation, then laying the remainder of the system up in adhesive. I think that that's a very effective strategy because you're getting the surety, if you will, of a mechanical fastening to the metal deck in most cases. And you can predict that, and you can get it down very quickly and get yourself a substrate to work off of for the rest of the system. And then laying everything else in adhesive, you've broken any kind of thermal connection from the inside to the outside, et cetera, et cetera. You can even do that with that polyiso cover board, by the way. Use that over the top of a mechanically fastened insulation. But the point is, in those cases, you're essentially going to be going through that air and vapor barrier, or that retarder. And most of those do require some sort of a primer, some sort of substrate. They actually can go directly onto the metal deck itself. And I have no hesitancy whatsoever. I know I've got some consultants out there cringing right now. No, you need to always put it on a board. These things are tenacious. The polyethylene sheet coupled with the modified bitumen asphaltic self-adhered back will take up to about a 425, 150 pound load on it. And if your roofers are that big, they're probably going to need to be getting out of the industry. Point being is that, I know, impact load, all that kind of thing. Point is, your likelihood of puncturing that is nil, if at all. And if it does occur, you can see that. It's readily evident right away. So I don't see an inherent risk in not putting down a cover board before you put down that membrane. But the beauty of this is it's self-healing. So when something does penetrate through it, particularly fasteners or something like that, it will self-heal around it as its thermal cycles. So this is just a good strategy. You see this thing in practice. I think you're seeing all the best things. These things are overlapped 3 to 4 inches. There's continuity, and you've got boards offset and staggered, high and tight. This is a solid system that's going into place. Bonding adhesives, another big challenge these days. VOCs, you can't see them, you can't actually smell them. It happens on a molecular level. Here's the real funny thing, right? Anybody here work with low VOC materials? They're usually the most offensive smelling stuff that's out there. Proof that low VOC does not mean low odor, okay? As a matter of fact, when people smell low VOC adhesive, they become very nervous. Working around hospitals, working around schools, working around public buildings, particularly consulates and government agencies where persons might otherwise want to get the day off or the week off or the month off because it smells bad. Funny thing is, it's more often not proof that they're in a safer environment. It just smells bad at that point. In any regard, the alternative to standard bonding adhesives have been those low VOCs. How do we achieve that most readily? Water-based adhesives have traditionally been the way to do that, but inherent problem there. Water freezes. Water sometimes doesn't thaw out real well. Water doesn't flash off real well in cold weather, or it flashes off too well in hot weather. So it's got a high degree of sort of reaction. Downside of low VOCs, aromatic, cold weather challenges, they don't flash off real fast. That's the beauty of standard bonding adhesives. They flash off really fast. They dry really quick, so you can lay them in. Problem gone. It's encapsulated. Well, they don't want that released into the environment. I understand why, but low VOC, longer time to dry. Difficulty on vertical surfaces. Don't get as much attachment purchase. And always more expensive. The alternative, solvent-free bonding adhesives. Firestone has a product out now that is a solvent-free bonding adhesive. Virtually zero. I can't say no because there is a micro of it, but 13 grams per liter. That's based on what it would be a very low VOC, would be 100 grams per liter, and 250 grams per liter is really sort of the low standard at this point. So at 13, it's has very low, virtually no odor. As a matter of fact, if I were to open up the can now and pass it around, you would have to stick your nose down into it to smell it. It's less aromatic than a Pinot Grigio. Any wine people there? Okay, Cabernet is very aromatic. Pinot Grigio not. Okay. Anyway, some work, some don't, folks. Beauty of it, single-sided, what we call wet lay. You only have to put it down onto the surface that's receiving the material. It's not two-sided. It doesn't have to flash off. It doesn't have to dry off. It's wet lay, half the time to make the installation. The only downside, still got to be 5 degrees, 6 degrees and rising, 40 degrees Fahrenheit. Yes?
You take the EPDM on apartments like that without covering it up with something, wouldn't that dry out the material over time? Should it be covered up with flashing or something?
Ultimately, that would be the case, yes. He's asking, would it dry out over time? Ultimately, that would be the case, but you've got a high degree of workable time with this material. It should be covered up ultimately, and that's why you're putting it down. Convention in roofing, only put down as much as you can tie off at the end of the day, and that's the way this works.
I've seen a lot of construction, they just leave it exposed like that.
And if it's a conventional adhesive, that would be okay to some measure. You don't want it to be too dry. Hot, arid climates oftentimes are a difficulty. Phoenix, Arizona, someplace like that, where it gets too dry and you can't get it to attach. So it has to be tacky. But that can, in conventional adhesives, that's anywhere from 20 to 35, 40 minutes. That's the other thing that's beautiful about this self-adhered, is that there's no flash-off invested in it. So dry, cold, doesn't really matter. It goes on. So.
Well, that's not my point. My point is the material itself gets exposed to the sun, beats down on it like that, and the roof is supposed to last for 40 years.
Oh, the material, no. I'm sorry. The material itself, the EPDM, will not be affected.
So the UV rating in it is that good that
It is
will withstand the sun for 40 years?
absolutely, absolutely. As a matter of fact, UV is its highest degree of resistance relative to any other system. Because if you think about asphaltic systems, even in the best chemical composition, they are subject to UV, no question about it. It breaks it down, breaks down the organics, the molecules. That's why we put the gravel, the aggregate over the top. That's why we paint them or finish them out with some other material to help prolong that life. Or the granules that might be inherent in the mod bit sheet. They're acting as a salve to protect that. And when we talk about the thermoplastics, they are certainly more prone to drying out or being affected by that UV degradation over time. The beauty of EPDM, synthetic rubber, it has the highest degree of UV protection built into it. Again, that carbon black does a lot to do that for it, and we have such an evolved and understood science to go with it. 40 years of manufacture and roofing coupled with close to 100 years in the tire industry. If there were a problem like that, we would have discovered that, we would have had that problem inherent much more readily on our automobiles. And you think about old automobiles, for instance. Sometimes the problem with owning a classic car is that the pipes and, the hoses and the belts and things like that would break down over time. Well, that's largely been overcome. When was the last time somebody here had to actually replace a fan belt because of UV degradation. Doesn't mean mechanical friction doesn't still cause problems, but so very good question. Thank you. And this is what it looks like going down. Yes? The white EPDMs, how does it handle the UV exposure? I'll be sincere with you. It does not have as much UV resistance as the black, but it has nearly equal. And the way that it's achieved is that what was carbon black in the upper layer of the manufacture of that is replaced with titanium dioxide. And that is a derivation, if you will, of the sunscreen that lifeguards use on their nose. Sort of a greasy granule kind of. The problem is, not the problem. The challenge is TiO2 is much more expensive. So that's what lends to it. But you can achieve and will achieve the same level of warrantability and longevity as you would with the black EPDM over the lifespan, but ultimately the black is more UV resistance. Okay? I'm being told that I need to wind this up because I've gone past my time, and my goodness, you've been an incredibly well-interested audience, and I really thank you so much for being here today. I hope that what you'll do is take an opportunity to take advantage to come and visit us at booth number 1308 or 1380? 1308. Come please see us and visit us at 1308. There on the floor. We can talk in length not only about Firestone Building Products, EPDM, but our TPO, our metal roofing, and our modified bitumens, and all manner of other products and systems that Firestone Building Products provides. Thank you.